Okay. Now, the question arises, I measured the thing, and actually it was closer to 78 centimeters. And somebody plugged that in to the calculator and found that for this model, that gives you 31.9 instead of 32.2, which means we were off by even a little more than we thought, although we didn't do badly. Considering that the model isn't totally accurate, the negative 0.6 isn't even the right number, it still works pretty well. Okay? Well, what I want to do now to address the question of how much change you would expect, okay? I'm going to estimate the difference quotient for x equals 75 and h equals 5. Okay? Now, the difference quotient is fx plus h minus f of x over h, right? And x is 75 and h is 5, right? So, oh boy. It's f of x plus h, x is 75 and h is 5. Then of course x is 5 and this is 5, right? And of course that's f of 80 minus f of 75 over 5, right? Now what is the meaning of that in terms of the graph? Because we want to come back to the graph in order to understand what this is telling us. Now we don't have time for me to drag it out of you. We've got 3 minutes left. I'm getting really sad. Okay.
Be sad.
Okay, so it's somewhat exaggerated. Here's 75 and here's 80, right? So here is the fundamental triangle. For that interval between 75 and 80, right? Okay, what's that have to do with this? Well, what we have here then, and here, we have f of 75 here, and f of 80 here. So our fundamental triangle, if I draw a slightly bigger version, well, what's the rise? It's f of 75 minus f of 80. I'm sorry, f of 80 minus f of 75. I labeled these wrong. This is f of 80 here, because, you know, there's the 80, and it projects over to here. Here's f of 75. 75 projects over here, right? So the rise is f of 80 minus 75, and the run is 80 minus 75, but that's 5, right? So what we have now is we have rise and we have run. Okay? Now, what's the meaning of the rise? It's the change in y, right? So, that's the change in y, which is a change in frequency. Okay? So the slope, now what else does the slope represent?
The rate of change?
It's the average rate of change. Average rate of change of what?
Y with respect.
Y with respect to x, but in terms of our situation,
Oh,
frequency with respect to length, right?
yeah.
Okay?
Yeah.
And that average rate of change will be in cycles per second, cycles per minute, per centimeter of length, right? If I get that, that tells me how much a 1 centimeter change within this range would be, approximately. Okay? Make sense?
Mm-hmm.
Okay. Well, that's how we interpret this. And this is the whole way we interpret. We interpret rise, we interpret run, we interpret x, we interpret y. We answer questions about the situation. Okay? So I'll be doing some more videos on that if you want to look at them. But, you know, the homework I've given you asks you to do that. Right? Asks you to tell me a story about it. Okay? I don't think I've seen a lot of stories. But if you can do that, you pull everything together with all the techniques and everything else we've learned and all the how-tos. Okay? So, okay.